Hey everyone, welcome back to our Unit 5 notes where we are working on our exponent properties. If you need to review what we have already gone over in the notes from the first page and in property 1, please go back and watch the class video from our Zoom class last week on Thursday. But where we are going to pick up right now is in property 2. And we have already, as a class, last week, worked on fully expanding and then fully condensing x to the third to the fourth. And what we learned, was that x to the third to the fourth is equal to, simplifies to x to the 12th. So we're going to look at 2 more examples of this and see if after looking at all 3 of these examples, we can develop a property which would be a shortcut to this expanding and condensing. Remember, as we talked about, we want to treat expanding and condensing as training wheels or diapers when it comes to simplifying our exponents. There will be times where they will work, but they are not going to be our best option, and there will be times where they're not even an option at all. So let's take a look here at our second example. And so what I want you to do, you can see we got started in it a little bit in class, is pause the video. And this is what we're going to do throughout this, this asynchronous video here to learn, is I'm going to ask you to pause it, try it on your own, either on a paper copy of the notes or on a piece of paper. And then once you've tried it, start the video again, and you can then see if you're correct here. All right, so go ahead and pause the video when I tell you to. After, and what you're going to do is fully expand 2x squared y all to the third, and then condense that, what you have after fully expanding it, condense that back so that it is a monomial with only one type of base for each base, with only one base for each type of base and one exponent on those bases. Ready? Pause. All right, let's see if we were able to do this properly. So as we already kind of saw in here, x squared is really x times x. So this would be 2x times x times 2x times x y, times 2xy, right? Which we can use the commutative property to move the like bases around next to each other. One more, and then y, y, y. And either of those would be a fully expanded form of that expression. Now, if we're going to condense everything, we can see there's 3 unique bases there, 2x and y. So then what we would get here would be a 2, an x, and a y. And you can see I have 3 factors of 2, so that's 2 to the third, 6 factors of x, and 3 factors of y. All right, so what we would have, as we've kind of done in red here, is I started with 2x squared y to the third, and that would be equal to, when we're done simplifying, 2 to the third, x to the 6th, y to the third. All right, we're going to take a look at one more example here. And then once we've got that one done, we'll take a look at all 3 of these red equations where we were able to take an expression and simplify it and see if we can find a shortcut here. So same deal as the previous one, fully expand, then fully condense so that each unique base in the numerator and denominator has its own exponent. Ready? Pause. All right, let's see what we got here. So we had x squared, which is 2 x's, and we had that 3 times the numerator. And we had y to the third, which is y times y times y, 3 times in the denominator. And I'll clean up that x to the 6th here. All right, there we go. And so if we condense everything, in the top, I have 6 factors of x, so that's x to the 6th. And in the bottom, we have 9 factors of y, so that is y to the 9th. So one more time, if I start with x squared over y to the third, all of that to the third, that will become x to the 6th, y to the 9th. All right, so I want you to take a look at those red equations that we wrote and see if you can find a shortcut to go from where we started on the left to where we finished fully simplified on the right. So again, I'm going to ask you to pause it, think about it, see if you come up with it, and then we'll talk about the property. Ready? Pause. All right, so let's talk here. Now, we discussed earlier that all of these properties can be written in an if-then format. All right, so the if tells us when to use the property. The then tells us what to do, how to use the property. So let's talk about the if part of this property. What we notice in all of these examples is that there are parentheses, there is an exponent outside the parentheses, and there are exponents inside the parentheses. Do not forget that even in this example here, the 2 and the y both have an exponent of 1, our ninja exponent. So hopefully you did not forget that as we were working up to this point with our property. So the property here would state if there are parentheses with exponents inside and an exponent, that's not how you spell exponent, let's try that again, exponent outside, right? So that's our when. You can see in all three of these examples that describes what's happening here. Then what can we do? What did we see happening in all of these examples? Hopefully what you noticed was then we can multiply the outside exponent by all inside exponents. All right, and that's our property 2. So what we have down below here in 1 through 3, and then 4 through 12 on the next page, and then 13 through 16 are examples that either use property 1 alone, property 2 alone, or property 1 and 2 combined. I'm not going to go over these in this video. I will leave you to work on those. I will fill in the correct answers with the work in the notes, so you will have a completed copy and answer key to look back on. But I want that to be time you spend practicing on your own. And if you have questions on those, I will be available during class time to answer questions on the practice parts. So work on those on your own time if you want to pause and work on them right now before moving on to property 3, or if you want to go through all the way through the video and get all the properties down and then come back and work on them, I'll leave that up to you. But please do make sure that you actually try those examples there using the properties to make sure you know whether you have questions or not. All right? So let's dive on into property 3 now. So we're following the same pattern where we are going to fully expand and then fully condense. But notice we're adding an extra detail here that we are going to be asking you to cancel any like bases, all right, before you condense your expression. So ready, pause. So let's see what we got here now. So if I expand the numerator, x to the 8th is 8 factors of x, there we go, and x to the 5th is 5 factors of x. So that would be a fully expanded expression there. Now we are being asked to cancel any like bases. Remember, if we're dividing the same value, whether that's a known value or a variable, they, in the numerator and denominator of a fraction, they cancel. So this x cancels that x and so forth until we run out of x's to cancel from the denominator and the numerator. And you can see what that leaves me with is just x times x times x. Now, you might be asking, well, what happened to the denominator? Well, guys, remember, anytime our denominator is 1, it's a ninja. It's invisible. We're not going to see it. Okay, so we do still have a denominator here, and I'll do this in a dashed line to show you that it is a ninja, right? If we really want to think about this as still a fraction, we can think about it as x times x times x over 1. But you do not need to write anything over 1. It is understood. That is why it is the ninja denominator. So what we have then when we condense that back together is x to the third. So let's take a look here at what we have. So I have x to the eighth over x to the fifth equals x to the third. And again, I'm just going to put this in here so we see it, is really x to the third over 1. So what's our shortcut here? How do I take x to the eighth and x to the fifth and get right to x to the third? Well, hopefully you noticed that, I'm talking slowly to give everyone a chance to see it on their own, that 8 minus 5 is indeed 3. So if, here's our win, if you are dividing the same base, so if we are dividing the same base, notice this property starts very similarly to our first term. If you are multiplying the same base or bases, right? I guess maybe I should say bases. So we will say bases here, right? Base or bases. Then what can we do? Then you can subtract the exponents of those bases. Now, here's the important thing, though. Subtraction requires order. All right? And so there are different ways to approach this property in terms of the order of the subtraction. I do not care if you have learned this a different way, if you do this slightly differently than what I'm showing you here, but the way I'm going to explain it in the notes is the order is top minus bottom. You can subtract the exponents, top minus bottom, and then here's the important thing, and put the simplified, come over here and go underneath, base in the numerator. Nope, that's a P, not an R. There we go, numerator. So notice 8 minus 5, top minus bottom is 3, and we put the x to the third in the numerator of that fraction, which the denominator is just 1. So if we are dividing like bases in the same term, we can then subtract the exponents, top minus bottom, and put that simplified base in the numerator. Again, there are a number of problems here to practice. You can see 1 through 6 works with only property 3. 7 and 8 are getting pretty hefty here, right? These are getting to be some pretty complex expressions here, single-termed expressions. This would use properties 1, 2, and 3 to fully simplify the expressions at this point. Again, whether you want to work on these right now and stop the video or come back to them, totally your choice, but please, please, please actually engage and work on these these examples here. All right, so 4. This is the easy one. All right, so what I want you to do is get a calculator out, and I want you to punch in your calculator exactly what you see in each of these examples. And notice where I put parentheses around a number, please make sure you put parentheses. So go ahead, get a calculator, and pause. So let's see. 5 to the 0 power. What you should have gotten is 1. Negative 8 to the 0 power. What you should have gotten is 1. 1,000 to the 0 power. What you should have gotten is 1. And 3/4 to the 0 power. Shocker. What you should have gotten is 1. Do we notice a pattern? Hopefully you do. All simplify to 1, right? So this is probably, guys, the simplest and easiest property. So what is the if? When can we use this property? If a base has an exponent of 0, right? This is essentially our property to deal with an exponent of 0. Then what do? Then we simplify the base with the exponent, just the base of the exponent, to 1. We don't make the exponent itself 1, guys. Notice this didn't become 5 to the first. It literally, the 5 itself became 1. All right. As we said before, there's a couple of examples to practice. Come and check your answers in the notes. I'll fill those in after the video and ask questions if you got any questions on those. All right, one more property to go here, property 5, guys. And again, this is one we talked about this. You cannot use expanding and condensing with negative exponents because it doesn't really make sense to multiply 2 negative 2 times. But what you can do is you can put this into your calculator, right? So there's 3 kind of steps here to get to the final answer, and we're gonna do it one step at a time, and I'm gonna ask you to pause after each one so we can kind of give you a chance to try this and make sure we're following along here. So first request here, first thing I'm asking you to do, put 2 to the negative second in your calculator and express that as a decimal. Ready? Pause. All right, so if you did this properly, you would have found that 2 to the negative second as a decimal is 0.25. Second thing I'm asking you to do, take that decimal and rewrite it as a fraction. And it is important, guys, that it is a fully simplified fraction. All right, ready? Pause. So 0.25, we should recognize that that's a quarter, and a quarter, fully simplified, can be written as 1/4. All right, the last piece here. Now, this is where it takes some thinking, and we're going to have to problem solve a little bit. We want to rewrite the denominator, that's the 4, of the fraction so that it is a base with an exponent. Now, to be fair, it already is a base with an exponent, right? We already know that 4 actually has a ninja exponent of 1. What we're actually asking you to do is to rewrite that. So instead of having the denominator be 4 to the first, we want you to change it so that it is a new base, a different base with a different exponent. So think of how you could rewrite and get the same value as 4 to the first, but you need a different base with a different exponent. All right, ready? Pause. So if you remembered your exponents from back in the day, you probably remembered that 4, or 4 to the first, is what you get when you square 2. So notice 1/2 squared is the same thing as 1/4 to the first. So let's take what we started with here and what we ended with and put them together. So we had 2 to the negative second power, and that ended up being equal to 1/2 squared. Now, always remember, as we've talked about before, there is actually a ninja denominator there. So you can see what happened is I had a base of 2 with the negative exponent of 2 in the numerator, and when we simplified that, I had a base of 2 with a positive exponent of 2, but in the denominator. All right? So let's put that into words. And I will tell you, this is a little tricky based on just this one example. So I'm going to help you out here and not make you kind of try and problem solve this, because I don't want you to draw the wrong conclusion based on just one example. So here is our when, and this is obviously pretty simple, straightforward. If a base has a negative exponent. All right, so if a base has a negative exponent, that's when we should use this property. Then what can we do? Then we are going to switch the position of the base. And let me just stop for a quick second here and say, what are the positions that we could have a base in an expression like this? Well, there's only 2 positions, the numerator on top or the denominator on the bottom. So if we zoom in here, that means top to bottom, or guys, we could go the other way. It doesn't always have to go top to bottom. It could go the other way, bottom to top. All right, so we're going to switch the position of the base, top to bottom or bottom to top, and here's the important thing, and make the exponent positive. And just so we are clear, if you have a negative exponent in your expression, it is not considered fully simplified. Same thing with an exponent of 0. It is not okay to just leave a 0, an exponent of 0, or a negative exponent in your expression and call it simplified. All right, so a few more examples to practice here with negative exponents in the notes on your own, and come ask questions. Last thing to talk about here, guys, is, and we've discussed this earlier, that these are properties only to be used when we are dealing with an individual term as our expression. If you have multiple terms in your expression, then you cannot use these properties on the expression as a whole. Take a look at these two examples. So in the first example, you can see we have a one-termed expression, 5x squared y to the third, all of it squared. One term because there are no addition or subtraction signs. I can use the second property to multiply the outside exponent by all the inside exponents and simplify. Here, a very similar looking expression, 5x squared plus y to the third, all squared. Now you can see, guys, in this expression inside the parentheses, there are two terms because we have an addition symbol. You are not allowed to just multiply the two by all the exponents inside. This right here, guys, this is sus, all right? It's not just sus, but it's cap. It is a lie, and it is no good. Don't fall for it. All right, same deal. Another example here, looking at property 3. I have a single term. There are no addition or subtraction signs here. So I can take the a to the 5th and the a squared, subtract 5 minus 2, and put the a to the 3rd in the numerator. Over here, again, very similar looking, but notice the difference in the numerator. We have an addition sign that means two terms. So once again, I cannot just take the 5 and the 2 and subtract them because that is not one term. Again, that is completely sus. You should totally accuse that equation of being the assassin and space them. All right, so just remember that. Last but not least, guys, I've taken all 5 properties, and by taken, I mean I wrote them over here, and I did that just so you wouldn't get ahead of yourselves and wondering what was over there as I zoomed in and out. And let me just make sure I got this all lined up nice and neat. Come on down. There we go. That looks pretty good right there. So in the notes, you will see I've taken all 5 of these properties, and I've kind of put them all here at the end. So as you're working through examples in the worksheets or study guides or formatives, instead of having to kind of flip through multiple pages or scroll through multiple pages, you can have all 5 properties with some examples right here at your fingertips on the last page. And that, guys, covers all 5 of our exponent properties. If you can master these 5 properties, these 5 shortcuts, you can simplify any single-termed expression when it comes to their exponents. All right. Well, that's all the knowledge I have to drop on you for the moment. Please put the effort in to practice this and come to class and ask questions, guys. I can't help you if you don't ask. I'll see you in class.